Hello and welcome back. Today is the start of chapter 12. Obviously, I am not in class, so we're going to watch this brief video. Just let it play. You'll get your points for the video. Then there will be a few practice problems to talk about. So today we're going to start our discussion on what similar figures are. Okay. Now, similar figures mean that the corresponding angles are going to be congruent and the corresponding sides are going to be proportional. Okay? An example of two objects that are similar would be like if we had a model car and the real car, right? The model car, everything about it is exactly the same except it's tiny. Okay, it's really small. Okay, in the same way, anytime we have a model, I don't know if you've seen, there's a big protractor in my room, but we also have a little protractor, right? And you use those at your desk. Okay, they're the exact same thing, just one's stretched bigger, but they're stretched in a way that the angles don't change. They're proportional. Okay, so if we look here, if these two shapes are proportional, basically if I would slide this up into the corner, my angles will match, okay? And if we can show that two angles are the same, then the third angle will have to also be the same because once you know that two angles are the same, third angle has to be the same because all triangles add up to 180 degrees, okay? And once you can show that two angles are similar, then you know that your triangles, once you can show two angles are congruent, then you can show our triangles are similar as they will be proportional. So let's talk about how could we prove that sides are proportional. If we look here, we can start with AB. What's the distance from A to B? And A to B is 2, B to C is 2, D to C is 3. Now we could find this using distance formula, but for now, we'll just move on. We'll just show how we know that they're proportional. So on the blue figure then, L to M is 4, M to N is also 4, P to N is 6. Okay, now, if we are comparing these two shapes, one thing you may recall from dilations last semester was something called scale factor. Depending on who your teacher was, you may or may not have talked about this, but with scale factor, if we take our result and divide it by the initial amount, you can kind of see what that scale factor is. So, for example, if we look here, AB, hopefully you can tell, like if that's my original amount, my initial amount, my result, AB, matches up here with LM, so that's 4 over 2. Okay, so my scale factor between those sides would be 2 to 1, or 2. We could check the other ones. You'll see on the right side, it's still 4 over 2, so 2 to 1. Now on the bottom, it's going to be 6 over 3. That still comes to 2 over 1. Now for this last side, it might be kind of hard to do, but if you think about it, this one is up 2 over 1. So if we go up 2 over 1, this one is up 1, 2, 3, 4 over 2. So it's double. Just like before, rise over run, rise over run, rise over run. It's twice as long. So each of the blue shapes is 2 times as big as the red shape. Since that's consistent, these would be called proportional. They would be similar, therefore. Okay? Now, if we look at this bottom one, are we able to show that these are similar? Let's check once again. So E to D, that's going to be 2. E to F, 1, 2, 3, 4. We can find D to F, but we'll deal with that later. Now for M to N, 1, 2, 3, 4, 5, 6. From L to M, that is 4. So once again, let's start off. We'll start on the left side. So if we get 4 for the red, we had 2. So that is twice as big. Now for the top part, do you see how it was 6 over 4? That actually reduces to 3 over 2. Those are not the same. If they're not the same, that means that this shape is not proportional. It is therefore not similar. Okay. Meanwhile, up here, we said they were similar. The symbol for congruent, is like this. When two things are similar, you just put the little squiggle from the top. Okay. Now, today, in addition to watching this video, you're going to need to do a few practice problems. So let me show you how to do the different types of practice problems here. All right. So the first type of problem will look something like this. It says, use the drop-down menus below, state the sequence of transformations that maps figure F onto figure G. Then use those transformations to determine, are these two figures congruent? Okay, so we start here at this one, figure F. We're trying to get onto figure G. So the first thing that happens, I don't know if you guys can see, it gets smaller. It shrinks. Okay, here's a dilation. It gets smaller. So a dilation with the origin, centered at the origin with a scale factor of, now for this, it starts off, I'll use this side. It was 1, 2, 3, 4, 5, 6. And then the result here is just 1, 2, 3. So if we put the initial on the bottom, the original on top, so that'd be 3 over 6, that reduces to 1/2. It's half as big. Now it's followed by that's a rotation. Okay, so a rotation, and hopefully you know that is 90 degrees, and it will be 90 degrees counterclockwise. Okay, now the two figures, are they congruent? And hopefully we know they are not congruent because non-rigid motion. Rigid is when it stays the same side. So we could still check, are they similar, but they will not be congruent. Okay. So we submit that, and that's how we do that. Okay. Now, the second type of question. Let me pull this up quick. All right, the second type of question, they are telling us these are two similar figures. So just like what we were looking at in our paper, they've already been proven similar, so we don't need to figure out if they're similar. We know they're similar. And it asks which side corresponds to side OP. So OP right here, it will match up OP to TV. It's kind of like a reflection, and it was stretched. So we're going to put TV here. And we'll submit that, and let's zoom out, and you can see it shows kind of this visual. OP flips right there, and it ends up on TV. Okay, now there's one more type. All right, the last type of question is comparing congruence versus similarity. So once again, we're going to use drop-down menus here. It says we are trying to decide, are these two similar or congruent? So CDEF, which that's over here, is not congruent. You can clearly see they are not the same size. So rigid motion cannot be used. So now the question is, are they proportional? And I hope you can tell, like EF here is 1, but it's not even really, there's no other part that's like flat like that. I guess up here SR, anyway, these are not similar because they cannot be mapped using dilations. There's no way to get between them. Let's do another one. That one was a little weird. Okay, so here, are these the same size? I hope right off the bat you can tell they are not the same size. So that means they are not congruent because rigid motions cannot be used. So now the question is, are they similar? Well, to check this, we can see, would there be any way to like kind of rotate or flip this to match up? And if we look here, there won't be a way. This one has like a horizontal side. It won't match up. So once again, it's going to be not similar. There's no way to make that match up. I want to show an example. Let me choose. I'll choose similar but not congruent, just to kind of show you what I mean. So here, these ones are similar. It's the same shape. It's just a much smaller scale. If you're not sure about this, do you see how from J to G, it's 1, 2, 3, 4, 5, 6. From that matches up with X to U, it's only 2. So it's 1/3 the size. Now if we look from I to H, that has a distance of 9. Meanwhile, from W to V, that's a distance of 3. Once again, 1/3 the size. Everything is 1/3 the size. So it is not congruent because it's not the same size. So it cannot be done with rigid motion. However, it is similar because it can be mapped with dilations. Okay. Now it says the scale factor from UVWX to GHIJ. So if it starts here, so I did it the opposite of how they did it. So it's going to be from UVWX. So it starts here. So this one, like UV, was a length of 1, and it's going to be 3 times as big. It gets bigger. So if it gets bigger, then you know this has a multiple of 3. Now let's make sure we understand. If this had said in the directions, what's the scale factor from GHIJ to UVWX? If it was from here to here, it was getting smaller, then it's always going to be less than 1. It's going to be a fraction. But that's not what we have. Okay. And then the final type I want to show, here they show the rotation and then the dilation. Okay, I want to show one example. What if it's congruent and so they're the exact same size? If that's the case, if they are congruent, then it is congruent because rigid motions can be used to map it. If they are congruent, are they similar? Well, remember our definition was for similar was that all the angles are congruent and all the sides are proportional. However, proportional could mean the same thing. So it is similar as well. It can be graphed by just rigid motions and dilations. Now this one, anytime they're the exact same size, it's going to be a scale factor of 1. Okay. So go ahead, get this done. If you have questions, let me know. I'll be happy to help you. I'll be back on Friday. Get some of the practice done, and good luck.